Whoa. Okay, welcome back. Hello. Bonjour. What's up? How's it going? Thanks for tuning in. I'm Agent Ultra. This is the wonderful stream where I build stuff in Haskell. How's it going, Damien Fry? Frau? Sorry. How's it going, buddy? Friend? Yeah, and so on the stream I build stuff in Haskell. I generally try to build the whole cloth projects. Nothing too, like, super advanced, but, like, big enough that it takes a while to work on something. Just kind of show folks what it's like to actually work in Haskell and use it as a programming language to build real things. We finished off recently a clone of asteroids, which went pretty well, I think. And this week, I've been working on like just random stuff lately, trying to find the next project to work on, and I think I had an idea recently for another little kind of small game project. So yeah, let's get into it. I'm thinking of this old game I used to play a long time ago. Called Trek, or like Super Trek. This sort of thing. We're not going to use any of the kind of copyrighted, trademarked stuff, of course. We're going to make our own version. We'll call it LambdaTrek. The gameplay is what we're going to go for. The idea is that we simulate a small... Well, we can simulate a universe, a galaxy, to play in. And the player... Let's see if I can make this a little bigger. Alright, the player is like a little ship in this galaxy. They have a certain amount of energy and a couple of weapons. They gotta beat some number of randomly dispersed enemies that are throughout the galaxy, kind of thing. And that's the gist of it. We could probably make our game a little bit more sophisticated if we feel up to it. You know, we could maybe do something with crew, or you know, maybe we could do some like AI for the enemy, something like that. But this is what I'd generally like to start with. Something pretty straightforward. It's turn-based. We'll make it command-oriented, so you have to like enter commands to like raise your shields, lower your shields, fire your enemy, find your weapons, that sort of stuff. And I think we'll do this with like a terminal UI this time. I would like to make it general enough with the game logic that we could maybe do a graphical port to this to like OpenGL or something, because that could be pretty fun. Make some cool little shader effects to make it look like it's on an old school CRT, that kind of thing. But for now, let's not get our ambitions too high. Let's start out with something simple. Because the spirit of these projects are to be like learning stuff and playing around with Haskell libraries and whatnot. So, yeah. As always, feel free to interrupt me if you have any questions, or you'd like me to like slow down on stuff and dig in, and that sort of things too. So, yeah, what are we gonna do? We're gonna start going to my projects directory here. We will create a project directory for this. We'll call it LambdaTrek. Okay, let's go to LambdaTrek. We'll use stack as our build tool. Just make sure I got the most recent version of stack first. Let's just update that stuff. Cool. This is the library I'm going to be working with for this project. I've used it before to make like little lightweight doohickeys and stuff when I was learning Haskell way back when. And like, you know, good for making roguelikes and things like that as well, because like you got a lot of, it's sort of like curses. You get widgets and libraries and it just renders things out for you. It's a little bit nicer than working with curses though, because the API is just a little nicer because it's good. It's Haskell. Not all libraries in Haskell have good APIs, but this one's pretty good. Okay, stack updated. Yes, okay. Let's start here. Okay, and then I'll open up my editor. Let's get going. Something made me want to play this game, and what it was is I've been watching the show. I've been watching The Next Generation again from scratch. It's probably like the 4th time I've watched this series in my life. It's aged in a lot of ways, and not so good in a lot of parts, but I still have a soft spot for it. I was recently watching The Best of Both Worlds with my kids, and they really enjoyed that. They thought the twist in it was good. The to be continued screen was probably one of the cliffhangiest in the series, I think. Okay, what did we get with our stack project here? Just a stack.yaml this time. Ooh. That's not a whole lot. I probably meant stack new. Alright, let's try this. LambdaTrek. Okay. I'm putting the wrong directory. Let's try this again. rm.fi. Do it for real. Yeah. Okay. Stack new LambdaTrek. That's what we want, I think, right? Boom. Okay. That looks a little better. Okay, package. That's what we want. LambdaTrek, boom. Great. Just a little setup here. Me. That's my email. Okay, not super interesting or cool or whatever, but let's see. Library, source directors, yep, that's all good. Dependencies. We'll add one for our library. We're going to need brick. Probably going to need others as we go, but we'll just leave that there for now. Executables. I'm going to make it lowercase. LambdaTrek. Okay, super. Let's see if this builds. Oh, that's great. You gotta be in the project directory. There we go. Okay, so it's gonna download all that stuff and get building. Alright, these are some cool packages that use it. There's an official user guide. That's great. Open that up. Okay, batteries included. I like. Vertical and horizontal box layouts. Multi-line text editor widgets. That will be great. We'll probably just need a single one for our command input. List and table widgets. Also good. Progress bar. Simple dialog box, border drawing, also good. I don't know if we'll need viewports and scroll bars. Hopefully we can just get away with not doing that, but... we need it, it's there, that's good. General purpose layout controls. A widget building API, okay, cool. So we've used another widget, like run UI API in here on this channel called Monomer for a text adventure game we built, like a graphical one. And a widget API as well, so hopefully this will be fairly similar. Customizable attribute themes, type safe, validate input form API. Not sure we'll need that, but check it out. Don't need that, but super cool. And borders. Awesome. Super. So this looks like it's going to be pretty good neat. Let's look at the user guide. For custom API conventions are worth knowing about as you read this documentation and write your own programs. Use of microlens. Okay. Also a common theme. Monomer used lenses to a degree. So Brick uses the microlens family of packages internally and also exposes lenses from many types. However, if you prefer not to use lens interface in your program, all lens interfaces have non-lens equivalents exported by the same module. In general, the L suffix on something tells you it's a lens. The name without the L suffix is the non-lens. It's good. Personally, I kind of like lenses. They make things succinct, but also not super necessary. Attribute names. Some modules export attribute names associated with user interface elements. Tend to end in attr. Example, border attr. Okay. Use of qualified Haskell identifiers. Okay. Okay, compile with threaded. Got it. Okay, so to use the library, we must provide with a value of brick.main.app. This is a record type whose fields perform various functions. Okay, so we bundled together like a draw function, choose cursor, handle event, start event, attribute map. Okay. And it's parameterized over these three variables. So these are type level variables that are generic, right? The application state is S by convention. Okay, the type of data that will evolve over the course of your application's execution. So to draw the interface, it takes the state, returns a list of widgets. Makes sense. Okay. E is event type. Type of custom application events that your application will need to produce and handle in app handle event. All pretty straightforward. Also very similar to Monomer as well. Resource name N. During application execution, we sometimes need a way to refer to rendering state, such as the space taken up by a given widget, the state for a scrollable viewport, and those click blah blah. Okay. Type N specifies the name of the application we use to identify these bits of state produced and managed by the renderer. Okay, we have to provide it. Okay. And then to run it, we pass it to break.main.default main or custom main along with initial application state. Okay. Sounds good. Alright, let's look a little bit more at the view game. Alright, we'll start off with this very, very simple simulation. In fact, maybe we just copy this, just to start off. fixed number of torpedoes, some energy, some shields, and that sort of stuff. So moving in our simulation should probably, everything we do should probably cost some amount of energy. Right. Maybe we could tweak like what those things are. So like there's going to be moving, obviously, like within a quadrant. Right. The galaxy will be made up of several quadrants. And then there's within a quadrant you can move, and then moving with impulse power or like your local like engines. And then moving between quadrants you need warp power. All right, these little things are stars. The dots are empty space that you can move to. So we'll have to have like some kind of local coordinate system and warp coordinate system. So that'll be pretty straightforward. And we'll need commands for changing the state of our ship, raising the shields, lowering the shields. Why would that be important? Well, like in, say, the Star Trek show, right, the ships, when they have the shields up, right, are being defensive, their shields can be lowered if they suffer enough damage or attack from attacks and things like that, like energy weapons and explosions and radiation and whatnot. And what's the other thing with shields? They can't fire their weapons with the shields up. What is the other one? Alright. So you'll lower your shields in order to fire things like phasers. I think that's true. I don't know. I should be. I've watched Star Trek so many times. How do I not know this? Anyway, so we might want to make that part of our games. That could be an interesting trade-off, right? Can you fire phasers with shields up? I think I'm right about this. Yeah, so shields will stop weapons fire from passing through in either direction. What does the Star Trek BBS say about it? Some theories about it. Okay, so they do like fire through the shields. Okay, so we probably won't need like a command for lowering and raising the shields. Unless we want to introduce something else that uses that mechanically in the game. So we'll just start with movement and firing weapons. And then reducing energy, I guess. And then we'll add in some enemies and things like that. Okay, we're almost done compiling our dependencies here. Brick is the big one. So let's start looking at some code. We're gonna start with library. The library entry point should be LambdaTrek. And we'll get rid of the lib thing, the lib file. rm lib.hs. Don't need that. We'll just call it run. add a little hello world. We'll update our application main here in app main. I'll import LambdaTrek. I'll call run. And that should be our main hello world. Get things started. I think the building going fine. Excellent. All right, let's run our game. Not much of a game yet, but there we go. Hello world. Perfect. Commit it. Ship it. 1.0. Here. Oh. I'm gonna rename it because I think the default now on GitHub is main. Okay, cool. And git ignores, or we got stack working. Okay, perfect. Let's add these. Boom. License. What license is this? This is the BSD3 clause, right? Redistribution of the source code must retain the above copyright notice. Binary format must reproduce the above copyright notice. Neither the name of the author, the names of other contributors may be used to endorse or promote products derived from this software without a specific written permission. Alright, that's good enough. Almost all the stuff I produce on the stream, of course, is shared and free to hack on, so there you go. Staged, good, commit. In the beginning. There was a license. Yes, there we go. Okay, cool. And let's create a little GitHub repo for our project. Let's create it. No template. LambdaTrek. Super-ish Trek clone. Written in Haskell. What's my... Oh, that's me. Boom. Here we go. Copy that. Let's add a remotes. And there we go. Skadoosh. Okay, so LambdaTrek. So all the code you're going to see here tonight is going to be here. If you want to go check it out, go ahead. Okay, so let's get brick going. Let's get our UI going. All right. I guess import brick. Let's set a variable first. Haskell process type. Stack GHCI. There we go. Import brick. Okay, and then I guess in run, we'll make this. Let's take this. Okay, import brick.widgets.border. Where do those come from? Widgets core? Okay, readme demo.hs. Okay. Check it out. Okay, here's the imports we need. Bang. Okay, we define this as UI. Got it. And then run becomes simple main UI. A little style element here. Border label. Stir hello. Press. Oh, it's just an unnecessary application here. Okay. Get our builder going. Fast. We'll use the file watcher. Okay, and we'll pop over into my other here and go to LambdaTrek and see this working. Exec LambdaTrek. Okay, seems to go well. I might want to pop out this. How do I don't even know this terminal all that well. Close. Okay, let's go over. Oops. That's okay. Let's create a whole other tab. Let's see if I can pop this out to its own window. Why can't I make it its own window? Windows. I guess we're gonna have to. Oh, that doesn't work. Not sure how much I'm gonna like that. Maybe we should do like a graphical window. Just because my terminal sucks. Can I open like a second one? Oh, I can. Okay. Never mind. Problem solved. Okay. Just so you can hopefully see it on the stream a little better. And LambdaTrek. There we go. So we got left, right. This is our TUI. That's pretty cool. We resize. Ooh, it's got resizing. That's nice. Cool. I like it already. All right, let's keep the building going. Okay, so that's our simple main UI. Good times. Yeah. Okay, let's split this off a little bit. Let's create a subdirectory, a lambda hack, and we'll just call it UI. Move that over there. We'll import it. So LambdaTrek.ui. LambdaTrek.ui. There. Arrow. Need to set the main there. That was from Brick. Oh. Oh, my bad, my bad. Let's go source. I made it lambda hack. Move lambda hack, which is a different game that exists. So LambdaTrek. Really me, I keep making that mistake. Hopefully that'll iron itself out eventually. Perfect. Turn off this warning because I don't like it. There we go. Remove export lists warning. Cool. All right, so our basic UI, let's just get that set up. This is pretty okay. I like having the title there. I'm thinking we'll have like the quadrant map on the left-hand side here, and probably take up most of the space. And then we can have like a thinner right-hand column for our status, data. And then our command input palette will be at the bottom here, maybe across both. Or maybe just across the left. Or just the right. We'll put the command palette on the right side. Yeah, I think that makes more sense. Okay, so how do I not make it even, but tell it to fill one side more than another? Adder demo, let's see. Okay, brick. Let's look at the guide. How do attributes? Maybe we got to set an attribute. Okay, so attributes form a hierarchy with the widgets. Let it go this way. Only parts of the attributes are going to change without having to repeat ourselves. Okay. Okay, so my map, adder map, W with adders, specific adder. Okay, and when it comes to drawing something on the screen with either of them, okay. What about BG blue? Okay, so we have a couple of functions for changing attributes per widget. Okay. And then we get attribute themes. Oh, cool. So we can get theming's already kind of built in for us. That's nice. So like users will be able to customize their LambdaTreks games however they like. Okay, that's neat. Base support, all that sort of stuff. Okay, maybe it's in the widgets documentation or something. Type, widgets, and rendering area, attribute map, active border style, okay. Viewports. Okay. Input forms, key bindings, join borders. What are extents? I don't even know what that is. Oh, okay, okay. Interesting. Okay. Nice to know. So when Brick renders a widget, the widget's rendering routine is evaluated to produce a V2I image of the widget. The widget's rendering routine runs with some information called rendering context that contains the size area to draw things, name of the current attribute to use to draw things, map of attributes to look up, attribute names, the active border style when drawing borders. Okay. How widgets use space when render describe two pieces of information in each widget. Horizontal and vertical growth policies. These fields have type size and can have the values fixed and greedy. These values are merely descriptive hints about the behavior of the rendering function, so it's important that they accurately describe the widget's use of space. Okay. Widget advertising a fixed size in a given dimension is a widget that will always consume the same number of rows or columns, no matter how many is given. Widgets can advertise different vertical and horizontal growth policies, for example. Okay, so these size policies govern the box layout algorithm is at the heart of every non-trivial document specification. We use VBox and HBox to lay things out, or use their binary synonyms. The box layout algorithm looks at the growth policies of its widgets it receives to determine how to allocate the space available to them. So, let's imagine the terminal window is currently 10 rows high and 50 columns wide. We wish to render the following widget. Rendering this to the terminal will result in hello and world underneath it with 8 rows, unoccupied by anything. Limiting rendering. If you'd like to use a greedy widget but want to limit how much space it consumes, you can turn it into a fixed widget by using one of the limiting combinators. Okay, here we go. This is what we need. H-limit, V-limit. So let's use H-limit on the right side. Maybe like this. $30. Oh, right. I have to fix this, aren't I? Yeah. Hey, H limit's not in scope. Is it H? It's H limit with a capital L. I did. Okay, this is why I don't like. I'm gonna get rid of those. Export explicit imports. Okay, there we go. And let's see what's the problem here. Put this inside some parentheses. It's probably just a precedence issue. Okay. That seems to have gone well. Let's check it out. Okay, there we go. That's better. So then if we resize this down, our left is filling as much as possible. Right is staying fixed. So we can squish left down quite a bit. Hello is staying kind of centered. That's pretty alright. Okay, how do we make, can we make sure left stays a minimum amount? Or like can't get smaller than a certain amount? Well, let's look at the brick API here. H limit. Percent. Support for constraining horizontal growth of otherwise greedy widgets. H limit percent. Try that. Okay, looks about right. Okay, now right will shrink down. And then we get kind of like a max, a minimum width, which is pretty good. I imagine our game will probably be pretty hard to play on small terminals without enough columns. I'll have to figure out what that will be roughly, and then maybe we can like fix it a certain amount. Cool. So we'll just change this to LambdaTrek. That's good. All right, we'll update source LambdaTrek UI.hs. Constrain the right panel to be 30% of the view width. Okay. And then we wanted it like a command port. It's like an area to put like a form input widget as well. And so let's do that in here. I guess we do something like this. Okay, yep, stacking on top of each other. That's nice. And presumably we could do like a v-limit. We'll make the commands like 3 rows. We don't need a lot. That's nice. Very good. Okay, so we got left, right, command palette. Brilliant. So there's the basic structure of our RTUI interface there. Maybe we'll put like a little V border between, a little horizontal border between the command palette and right. Break this up and make this code a little nicer. And then we'll be good to go. I want to do that now. So we'll make a command palette. Palette? Let's spell palette. P-A-L-L-E-T, right? Yeah. Widget. So we'll just take that. Replace it. There. Don't need that there. And need that there. Yeah. And we'll put, I guess we'll put a V border, or H border, sorry. Like this. You know, you got a pretty decent API when your user can just kind of like look at a few examples and then start guessing how it should work, and it just does. That's nice. I mean, most things, I'm not opposed to like having to learn things in order to use them, but it's nice when you can get a little bit of that going. I feel like you're onto something. You're onto a good API when you have that going. Anyways. Okay, so we'll break this one out into... Well, center right is the actual... we'll call it like the info widget. We'll call it the info panel. I don't want to overuse the word widget here. Info panel. Alright, we don't need that open parenthesis there. Over there. Probably need it right there. Oh, what am I doing here? Burr, 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 burr. That wasn't the invitation. Oh, it's up here. No? No? Got a mismatched one somewhere. Oh, okay, yeah, there it is. Sweet. And everything should just look as it was before. No worries there. Okay. So, let's... What should we handle next? We need to... take input. Alright, we need to process commands from the user. So let's figure out how to do that. Maybe, like, actually, the only thing I want to do here is just give a name to the sim display. Just in preparation of us, like having to customize that widget. Okay. Okay, so let's create a new module then for the commands in LambdaTrek. Call command.hs module LambdaTrek command. All right, so we're gonna have a few. We'll have impulse move. I don't know if I should use that term. It's a fine-ish term. Jump move, we'll call it. Well, I could call it, instead of impulse move, like local move. Or engine move. And then jump move. Okay, let's just start with those. EQ show. So for engine moves, we're going to need the coordinates within the quadrant that you want to move to. Alright, same for jump moves. We might represent those differently just to make them distinguishable in the interface, so you don't go like 10-10. Is that a quadrant or is that a sector? Whatever. So let's use. Let's create a type for these. Let's create a module for units. Haskell Cat is here joining us now, aren't you? Okay, call it units. You're gonna have to move Haskell Cat, you bitch. Yeah. I'm on the stream. You're too big to sit there. Alright, we'll call it units. Module LambdaTrek units. We'll call it quadrant ref units. Let's just say, like, the original Trek was like an 8x8 quadrants. So you had we could do like letters. That ought to be enough, right? 16 letters. A, B, C, D, that's 4. F, G, 1, 2, 3, 4, 5, 6, 7, 8. 9, 11, 12, H, I, J, K, L, M, 13, 12, 14, right? 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I don't. I'm counting it out one line at a time because that's just, yeah, whatever. Anyway, yeah, deriving the show. It's like counting on my fingers when there's line numbers right there. Right, so we can get a quadrant ref, and that should be good enough for... Or... So really we're going to be referring to them in terms of... No, that's good enough. That's good enough. No, wait. Design decision. We also want a coordinate based off these quadrant refs. Right? And this would be like, it's like a V2, a vector, a 2-element vector of quadrant ref. Or it could just be even simpler, just a tuple, right? Although, because we could just make this the type rather than these, and then we could just have a smart constructor for that. Well, we don't need the chords yet. I'm happy enough with jump move taking quadrant refs. That would form a valid command. Alright. So that should be good. Except when we render... Well, no. We could do jump move like AA and that wouldn't make sense. So we want to make... When we're writing like Haskell code, one good rule and like kind of maxim to live by, or at least try to and to aspire to, is to make unrepresentable states unrepresentable so that you don't have to worry about validating your commands all over your code. So in this case, right, this jump move command would be invalid. We could write a parser for... Well, we are going to write parsers for commands, actually. And so the only way to construct commands will be through that parser. And so our code can assume that the quadrant refs are valid quadrants in the map that handle it. Otherwise, we have to make it so that you can't even construct this with jump move AA. Because I'm thinking the way we're going to lay out the grid basically is that we'll have like 8 of them at the top, A through whatever, and then the rest across like, down the side, right? And so they shouldn't be AA, it should be like AH. And that would be a valid quadrant. But we shouldn't be able to have a quadrant AA. So we could predefine the map of valid quadrant refs, our coordinates. Yeah, and then we could validate jump moves against that while we're parsing them. Or we can, instead of doing that, we could parse out the actual coordinate that we want to jump to. Yeah, we were probably right on the right track when we wanted to do quadrant coordinate type. When we wanted this type, this is probably the right thing to do. So another handy strategy for making unrepresentable states unrepresentable in Haskell programs, because like that's a wonderful little maxim, but like how do you actually do that? Is to keep related data that depends on other data, like that data that should be together lives together, and they live together in a type. As you notice, if we put the quadrants independent of each other, right, that is what enables the jump move command to have this edge case of jump move AA, right, or whatever I call the type. Quadrant. That's what allows jump move AA to be, and that's what requires us to validate. And then we'd have to check at some point that the jump move is valid, and then yada yada yada. We put these two things together. Right. Now we have to parse a quadrant coord in order to construct one, but then we have the chance to do the validation in one place. And now jump move, using that parser for this type, can't possibly get it wrong. Engine move, I think we'll be fine, because the way I'm planning on doing that layout is to have them numbered, and this will just be X and Y. We can add comments to that effect. Move the XY of the current quadrant. Jump to the quadrant. Line those up. That's nice. Yeah, I think that'll be a bit nicer. Let's go to quadrant coord. Let's go to units here. Let's define. We'll create a new type. Quadrant coordinate. I'll get quadrant coord. And it'll be a tuple of quadrant ref. Let's pull that over to the left a little bit. We'll drive our usual EQ and show for that. Cool. So instead of, like, typically when I'm designing a module, I'll usually export everything. If I want to be super, super safe and like really tell users that like, hey, don't use this constructor, even though sometimes it's useful to have it in scope, I'll create like an internal module underneath this module where I will export this constructor name, and otherwise only export the smart constructors from the main interface. And that way, if you really need it, because you know what you're doing, you're going to import from the internals, and that kind of signals to other programmers that, like, hey, I'm using some things here that this wasn't designed for. Be extra cautious reading my code, that kind of thing, right? So we might do that here, because I'm gonna use, and that's usually how I do smart constructor. Like, doing the smart constructor pattern and not exporting this constructor at all can be really annoying with Haskell. So that's the way I usually do it. But if we want to create a quadrant coord, we need a function. We'll take a quadrant ref. Another quadrant ref. And we'll return. We could just do, it's either valid or not. Alright, the types restrict, the quadrant refs restrict the input types to a very small set, like a numerable set, so yeah, let's just use maybe here. I might regret this later on, but it should be fine. So maybe quadrant coord. We'll do like X and Y as the kind of convention. Probably should note that here. Okay, so we could even break this out into like quadrant ref X and quadrant ref Y and make this even simpler. Okay, so here. Yeah, 1, 2, 3, 4, 5, 6. Oh, well, less than that. H. Okay. Oh, I got it. There, change this to an equal sign. There, we even split it out there, so now it's absolutely certain we can't mix them up. We don't even need this comment anymore. This is a little bit nicer. In fact, now we don't even need a smart constructor. Because you can't even get it wrong. That's sweet. I like that. To make writing quadrant coords nicer, I wonder if there's like an is tuple. Probably not. That's okay. Because maybe we should make it a record, because I'm already wanting to add accessors. So maybe tuple isn't the right thing here. Get quadrant coord Y. type that all out. Well, I'll leave it. I'll just call it quadrant. Okay. We go whole hog on this and we use lenses ourselves inside the game. We can even make this accessing these resonances. Anywho's, let's just do it this way for now. Pretty simple, pretty straightforward. No biggie. So yeah, now our coord should be an exported type. What's the problem here? Just type it wrong. Yeah, maybe it's just not cut off with me yet. That's okay. Okie doke. So those are our two commands. Now we have engine move and jump move. We can write a parser for these pretty straightforwardly. We can probably use... We could use like a heavy-duty parsing library. Like Mega Parsec. Probably a little overkill. Probably a little overkill because like I'm thinking our commands are going to be mostly of the form like MOV for engine move 233 and JMP for jump move, and you'll give a quadrant coordinate like AH or whatever, AI, and that kind of stuff. We might be able to get in with a built-in parsec library for that. Let's see, parsec, I think is built into base, which would keep our dependencies down. Not that parsec. This is not a library you want to use for like most general parsing tasks, but for like little tiny tasks like this, it might be fine enough. I think this is the built-in one. No, this is parsec the library. This isn't the one. Haskell base. There is text parser combinators. The API for this library is not great. I'm just gonna warn you. It's not fun. I've written a compiler using it. A parser for that compiler using it. Just because I was doing the Nantu Tetris course. And they claim to support Haskell. And they do. But I didn't know like to what degree they like supported all like Cabal, for example, and all the build tooling that you need to like compile a modern like Haskell application or a Haskell application. And I didn't want to like waste too much time figuring that out, so I just like kept myself to just using base and nothing else. Super fun. But let's see if we can get away with this. Let's try it out. All right, so I'm going to create a command parser parse.hs. Yes, create a directory. LambdaTrek command.parse. Import text.parser combinator readp readprec. Weird naming too. So it's here and available when you want to write like a quick and dirty parser for something. But I guarantee you it's gonna be rare. Okay, so like a lot of the libraries that came after this, Parsec and friends, kind of same applicative parser combinators is a general idea. They all kind of function the same way. All right, so we create these readp parsers, and then we run it. And we have different combinators for combining together smaller parsers into bigger ones. So let's create one. Let's parse the move command. That one's pretty easy. Let's keep our module open. Command module open. Engine move. Alright, this is going to be a readp. Or is it readprec? Readp.
Hello? It's Joe. Where are you? We're waiting for you.
A readp of command. Okay. We're going to first parse a string, so we'll see. I think we have a basic one here, string. All right. We'll do move. All right, we're gonna throw away the result of it though. We don't really need it. So I think we have to underscore like that. By to go to result. Oh, I can just do a string move. To combine, if it gets mad at me, let's see. Give it a real old school feel and keep that one little character off the end. Alright, okay, and we're getting, yeah, because we need our LambdaTrek command module. Leave that up there. Okay, so after we parse a move, we need an int and an int. An int, a space, and an int. Do we have like a number? Yeah. Digit, maybe. Sometimes I call it digit. Okay, well, other modules have something like this. Okay, so we're going to need to write our number parser as well. Do we have a space? Skip spaces. And then we want X digit. Skip spaces. Y to be digit. And that should be it. That should be good. And then maybe EOF. Then we return the engine move command, X and Y. Okay, we don't have that digit in scope, so we need the digit parser. Cool. So we're gonna need like a read many such that satisfy. Sounds good. Consumes returns the next character. Satisfies the specific predicate. We need one that returns more than one though. Keeps munching them until it gets there. Munch. Parse the first 0 more characters satisfying the predicate. Always succeeds. We need munch 1. Parse the first 1 or more characters satisfying the predicate. Fails if none, else succeeds exactly once, having consumed all the characters. Okay. Munch 1, I think, is the one. Call that B's, we'll bind it to D's. Munch 1 is digit from beta.car. We have to do something with D's. I think the secret was in data.lex. GHC.read also has one. Reads S. And there's a couple of other options. Text data.text something or data.read in base. Text.read. We could read your ints. Oh, okay, interesting. Reads prec. Also in base from our parser combinators. And we can convert it to a read P. Oh, okay. What's the difference between reads prec? Oh, precedence parsing. I see. Yeah. We don't really need that a whole lot. I just want the Maybe it's under Lex. Read int p, yeah. Read int p takes some number a, two functions, card bool and card int. There's also, I think we can also just do, I believe there's like a read function. Yeah, restart the GHC process, please. We read int like this with like 334. Yes, I meant to enable tab pages. Alright, we get 234. Now, in the parser, we know, at least at this by this here, that ds is only going to contain digit characters. So using read in this way should be safe. So read these. Yeah, so this kind of suppress them like that. Cool, so that all compiles and does things. Then in order to run our read p, and then we have to run it. So this is the main way in which you can run a readp parser. Command type is readp2s. Yeah. So the read functions in this what kind of sucks in my opinion. This library, it's not super fun. So import text.parser combinators readp. So then we do say digit. Alright, so it returns this list with the tuples. And so we should be able to do parse engine move. And it'll parse engine move like that. Bang. So that's good, that works. Parse jump move. Very, very similar. But we're going to have different parsers instead of digit. We're going to have quad ref X and quad ref Y. This is going to be pretty easy parser to write. quadrant fx, LambdaTrek.units. How are we doing for time? Not too bad. So we're gonna get a Kalaka and Ours returns the character. Oh, we have to specify the character. Let us... Oh, I just want to parse the next character. Oh, there we go. Just get. That's good. Get. And then we're just going to case match on C. Right, and this is pretty much going to be what we find in units. Just grab that boss. Pop it over here. Faster, but there we go. Burp, burp. No, that was not the macro I wanted. Try that again. There we go. Just like that. Oh, we're gonna need to add pure on top of that. What's the problem here? All right, quad. Parse quad ref Y. Repeat quadrant ref Y. And like that. And we're not doing an engine move, we're doing a jump move. Where we have forward X and Y. And then we have just some non-exhaustive case matches here. So we should just do fail. Coordinate. Logic quadrant X coordinate. And like that. Yep, yep. Steal that, steal that. Just change that to Y. And we're good there. Perfect. So that's parsing those two, and now we can combine them together. Parse command. Parse command will just be one of. I think we got that combinator in here. Choice, maybe. That's the one we want. I think it might be. Parse engine move, parse jump move. So we do parse command now. We get engine move, or we can get JMP, A, H. And parse it all. Q. There we go. Right, and that's actually kind of interesting. H, of course, is not a valid parse quad ref Y. It just gave us the empty list, though. Which is kind of why this sucks. Like if I just try to run parse jump. Move. Yeah, we just got the empty number. So the fail doesn't even like trigger here for some reason. It just gets swallowed. Maybe we should put error? Although that might go to the IO exception channel, and that might not be so nice. Yeah. Still just empty. Oh, I didn't reload it though. Yeah, that's not as nice. We don't want an IO exception. Because that would halt our program, and that would just be no good. So, yeah, I'm not a huge fan of that. How do I signal errors? Maybe there's a way to do it in the library. P-fail. Interesting. Or just that's just a parser that always fails. Okay, right. Might not be what we want. Yeah, so, I'd like to have some kind of error reporting that is beyond just the empty list. that might be fine enough for this game, because the commands aren't going to be terribly complicated. So we're going to write our own little wrapper, basically parser to run our parse command. Run parser, run command parser. And that will be, you give us a string, and we will return maybe a command. Okay. Gives command string and maybe a command. So then we will do case, and we'll just basically do well, the first thing we got to do is run the parser. So we'll do readp do s parse command on our input. That's going to be basically 0.3 there. Alright, this whole is going to be a list of commands and strings. This is like a line-based parser, so we don't have to worry about part consuming more input. So we're just going to use readme. Our list to maybe. List to maybe comes from data.list. Or is it data.maybe? Data.maybe, sorry. Data.maybe. So now we have this whole of the shape, maybe command string to maybe command. So we're going to fmap in there first. Reach into that maybe, pull out the first element of the tuple. And put that in a new maybe. Alright, so now we should be able to load this up, run command parser, move 23, 23, just an end and move, we do jump, A, we get nothing, if we do like AQ, that's a jump move. Okay, super duper, we're running a little low on time, we've got command parser going, let's just commit that. Parser. Okay, now let's just hook this up to the UI quickly. Well, that's going to be a whole thing, isn't it? Let's see. Back to brick. I don't think we're gonna have enough time for it because we're gonna have to like learn Brick's input method and come up with our input widget and stuff like that. So we'll do that. We'll save that for next week. So yeah, here's what we got so far. All right, this is our general UI structure. We're gonna fill in next week the command input thing here, so you'll be able to input your commands. We have the parser already set up, ready to go. Parsing that'll handle our commands, and then yeah. We'll have a renderer for rendering the current quadrant. We'll map there, and then we'll have the right displaying our info about the game state. And that'll be LambdaTrek. So thanks for tuning in. I hope this was educational, maybe, entertaining somewhat, hopefully, and all around just good times and chill vibes. I usually do these streams once a week on Tuesday evenings in the Eastern Standard Time Zone, Eastern Daylight Time Zone, whatever those time zone things are, around 10 after 8 in the evenings. So if you're on the Twitch and you want to, follow along, then just click that button, follow, turn your notifications on. You'll get notified when I go online. Sometimes I do surprise streams every once in a while on random things. And you can tune into those too. You get those notifications right in your inbox or right on the Twitch app or whatever it is. If you're on YouTube, of course, watching in a different time zone, you know what to do there. It's been great having you. Also, check out this link above here. This is got a link to our Discord server where there's a lot of other streamers doing other streaming in different languages, including Haskell. But we also have a channel for this channel here. A channel for this channel. Where you can, chat about your projects, ask questions you didn't want to ask on the stream, that sort of thing, and interact with me behind the scenes. And of course, I'm also on the socials on the Fediverse. I'm on the types.pl server. I'm Agent Ultra. The code for this project, let's get that pushed up now. That's on the GitHubs, as I showed at the beginning, in case you missed it. It is Agent Ultra / LambdaTrek. That's where it's going to be. Let us rebase and restructure all of this here. Squash those up into add basic UI. Yes, I like that. Good. Add a basic UI, constraining the right panel to be up to 50% of the view width. We have a command panel for input on the bottom of the right panel. The left is for displaying the simulation. Okay, pushing that up, and there you go. So you'll be able to get that code there. Good chunk. Happy hacking out there. May your monads always be free, and may your types always check, and I'll see you soon. Take it easy.